Thank you,
And that's
Shandy,
it.
and thank you, North San. Thank you, Sandy and Flycaster. So, yeah, my name is John McMillan. It's good to present to you folks again, and so I think last time I talked, I kind of went through the Elwah Dam removal project and provided an update on what we've been seeing. So we're about a year and a half after my last talk, so I'll try and give you another brief update on the Elwah, and then I'm going to dive into kind of four factors that are I think, kind of relevant to the future of wild steelhead and our ability to fish for them, because I think as um, anyone who loves steelhead knows, we're going through some tough times right now. So I'd like to have kind of a frank discussion about the challenges that steelhead face, but also underscore that, it's not like they're going extinct anytime soon. There's a number of things that we can do to kind of allow the fish to keep pace with climate change. Uh, For those of you who don't know me, maybe didn't see my talk last time, I grew up on a Steelhead River in Southwest Washington called the Washougal, and I've been steelheading since a very young age. I think I landed my first steelhead on a fly rod around age 3, and that's just kind of carried over to my adult life. I really love not just steelhead; I love all salmonids. I love wild rivers and places, and I love nature. And I've been a professional research scientist for 26 years now. Um, I had spent most of the past 8 years working for Trout Unlimited's Wild Steelhead Initiative. But as Shandy mentioned, about 2 years ago, I left that position to take a job with the Conservation Angler, which is where I'm at now. And my reason for doing that was twofold. One is I wanted to go over to Russia and see untouched populations of fish. Um, that's on hold. But two is I've lived through these declines twice in my life now, in the 90s, and now here we are in the 2020s. And so the second reason I moved on is I felt like I needed to be with take a more aggressive approach to try and conserve our steelhead. And as much as I love TU and have a tremendous amount of respect, they have a set of broad relationships. So I'm kind of working with a couple of lawyers now and try and find ways to use legal means to, ensure that agencies and other people, corporations are meeting their policy mandates. So I'll start with a brief update on the Elwah River. And before I get into that, I want to reiterate that all the data that I'm going to present here tonight from the Elwah is due to a really large group effort, collaborative effort, with a number of scientists, everybody working from the lower Elwah Slalom tribe to NOAA to the Olympic National Park Service. So there's a lot of names on here. This doesn't even account for all of the people that have really contributed to the project. But just to be clear that I'm just one small piece in this big cog. Uh, so those of you who aren't familiar with the Elwah, I'll just provide a map to kind of get us up to speed from last time. Um, Two dams were built in the early 1900s. Elwah Dam at River Mile 5 and the Glines Canyon Dam at River Mile 13. Both were impassable. So just having the Elwah Dam in place was bad enough to block anadromous, block access to 90% of the anadromous habitat that steelhead, chinook, coho, bull trout, pink, chum, and sockeye used to access. As a result of blocking off all that habitat, of course, there was a dramatic decline in all these anadromous species, and we estimate now that it reduced the salmon and steelhead abundance by about 98% from its historic levels. So, of course, there was a big push both by the lower Elwah tribe and a number of other concerned groups, including Trout Unlimited, resulted in about a 30-year effort, 40-year effort of lobbying in DC, and finally the dams were removed. The lower Elwah Dam was removed in 2000 and late 2011. Glines Canyon was completely passable and removed by 2016. So about 5 years apart. And the scientists working in the basin are using a number of different tools, things ranging from smolt traps to red counts to sonar and snorkel surveys. I'm not going to get into all of that. I'm just going to provide an update on where Chinook salmon and steelhead are at, because those are kind of the two big species a lot of people think about, and they have responded a little bit differently. So we'll start here with Chinook salmon, and you can see the little arrows down at the bottom, one pointing around 2011 or 12, another one around 2015 to 16. And again, that just highlights the years that the dams were removed. And on the bottom, you've got, all the years of data that were collected, including many years before I started working on the Elwah. And what you've got are total run size, which are the dark filled in black circles. You've got in-river run size, which are the gray circles. And so before the dams were removed, all the estimates of Chinook abundance were conducted by using red counts. There were only 5 miles of river. It was pretty easy to walk it and count all the reds. Now, of course, visibility in the stream was greatly altered and reduced because of dam removal and all the sediment. So we've been using sonar to estimate run size now. And so you've got, again, on the right-hand side up here from 2011 onward, you've got some open circles with a line through it. That's the total run size. And then you've got in-river run size down with the gray circles that are filled. And the reason for the difference is that some of these fish are taken into the hatchery, and some of the fish simply don't seem to survive for whatever reason. So there's a difference in terms of the in-river and total run size. But the most important thing to look at here, and this is a largely a hatchery population. So the Chinook were limited to lower 5 miles of river. This hatchery has been running for a very long time, decades. And so what we're seeing is that hatchery population has actually been displaying better survival, and we're seeing an increase in the total number of Chinook post dam removal. I mean, we're not back to where we were in the and some of these run size in the 90s, but you can see that things look better now than they had for most of the last 20 years for Chinook. And in a slide coming up, and I'm going to get into the juvenile Chinook salmon and how many of these might be naturally producing in the Elwah River, because that is the goal, of course, is to generate a naturally healthy, self-sustaining population of Chinook salmon, and then hopefully to close the hatchery at some point. Of course, we're a ways away from that. So these are steelhead adult run sizes. And again, what we're using here are sonar. There were only 2 years of red counts for adult steelhead before the dams were out, because it was a very small remnant population of wild winter steelhead, anywhere from about 100 to 350 fish. Some years saw a little more, but it was a very small population limited to the lower 5 miles. And so what we see here is there has been a pretty sharp and dramatic increase in the total number of wild winter steelhead that we're seeing returning to the Elwah. The year before last was actually the largest run on record that we've had. This population was founded on hatchery fish, but there were also wild fish. So the contributors to the recolonization have been a mix of hatchery and wild fish. And over the past couple of years, it's been about 60 to 70% of the fish are wild, 30 to 40% are hatchery. But the major point is that both of those fish, wild and hatchery, appear to be contributing to recovery of the population, increasing numbers of abundance. We're also seeing an expansion in red spawn timing and the time of entry. So when the dam was in place, almost all the steelhead entered sometime beginning in March, and they would spawn sometime in late May through June. And now what we're seeing is steelhead are beginning to enter as early as December. They're starting to spawn as early as late January. So the original diversity in their tapestry, their kind of evolutionary tapestry, is starting to return, which is a real positive sign. And of course, what makes this all the more interesting to me is that we're seeing increases in adult returns of steelhead during a period in which almost all the other populations in the Pacific Northwest are struggling. So the big question is, can we get, how much natural production are we seeing? Because we didn't have a lot of natural production of Chinook in those lower 5 miles below the dams when they were in place. So what we're seeing here is, again, on the bottom, around 2012, 2015, you have the arrows indicating the years the dams were removed. And these are numbers of zero-age Chinook salmon that are caught in a smolt trap that exists at the mouth of the Elwah River. And what you see is that very few smolts were actually caught and during the years in which the dams were being actively removed, right? There was a lot of sediment that came out from the reservoirs and lakes behind the dams that likely decreased the survival of juveniles in the river. But since about 2016 to 17 and 18, the river has started to stabilize, and now we're basically seeing background levels of sediment. So the river's at a place where it's finally, reached a stasis level. And not surprisingly, we saw a dramatic increase, and those are thousands of fish over there. We saw a dramatic increase in the number of juvenile Chinook that are being caught in the smolt trap. So again, just another positive sign, because when we're seeing a lot of adults, and if they're all from a hatchery and we're not getting a lot of natural production, that would suggest that maybe something has happened right in the river. But it looks like the predictions and the forecasts that we thought would come true are, which is that as the river conditions have stabilized, the Chinook salmon production has really ramped up. And we see basically kind of the same pattern for steelhead, right? We did not see very many steelhead smolts coming out during those years in which the dams are being actively removed. And now we're seeing a much higher level of natural reproduction. So overall, I think that the Elwah remains this, beacon of both hope, and it's a lesson for us all that, dam removal is one of the levers that we have to turn to improve the status of our fish. And in the Elwah, things look good. So I'm excited about the same happening down in the Klamath, of course, and look forward to seeing what people find there. I think now I want to talk a little bit about the future of steelhead and steelheading, because I think, as Shandy is aware, and a lot of people are, there's kind of been this large synchronous decline. Just a few years back, the Skeena, I think, had a total run size of about 7,000 fish, was lowest on record. It usually averages somewhere in the 15,000 fish range, 20,000 fish range. And so 7,000 fish in the Skeena is really bad. It's had run sizes over 50,000 fish. And so I'd like to talk about the challenges that steelhead are going to face moving forward, and why we're starting to see signs of that now. And I think the fundamental question for me and a lot of other scientists is, can steelhead keep pace with all of the climate change effects that we're seeing? We're seeing a warming spring. So the big question for me is, can steelhead keep pace? I want to talk a little bit about changes in weather, competition they're dealing with in the ocean, and then changes in run timing. And I also at the end want to talk about an emerging body of research on how sport fishing, including catch and release, impacts the productivity of steelhead. So the first challenge I think we face is that, look, the planet's getting warmer, and we're experiencing a much greater level of variation in weather, both heat and drought, and rainfall and snowfall. And this figure just basically shows drought area and intensity by year from about 1980 to 2014. And you can see that it just looks like the frequency of extreme and exceptional droughts are becoming more common. They're happening basically, almost every year since 2000. And a Climate Central report in 2022, to put this in context, suggests that the average summer warming by 2100, they looked at 247 cities. And by 2100, we're looking at about 8 degrees Fahrenheit. And the only caution I would say is these models are likely underestimating how much the temperature is going to change because we don't fully understand all the mechanisms. But basically, they estimated based on their analysis that by 2100, the average summer temperature in the place you live now will be more like a city or an area that's 437 miles to the south. So if we think about the Olympic Peninsula where I live, that means by within, about 75 years, the climate where I live now is going to be much more like that of the Oregon-California border on the coast. If you live in Roseburg, it's going to be like Modesto or Fresno, almost a Central Valley in California.
Dare you say that?
Yeah. So this is something that I think, when we talk about climate change, it's kind of a nebulous, very obtuse thing that's kind of hard to grasp, in terms of how much things might change and what it might look like here. So I thought this study was kind of useful. It gave me a little bit of a different perspective. And I've been seeing this on the Olympic Peninsula where I live, and other people, of course, have been experiencing it too. So the challenge, of course, with warmer, drier summers is that can really impact the amount of stream flow that's in a given river. Some of these streams can go dry and dewater and kill fish. And larger streams, even though they might not go completely dry, they can become very hot, and the flows can become so low that fish will just stop migrating upstream. And this can lead to a variety of impacts ranging from disease to loss of fat stores that they need to complete their migration. And so this is just a picture of the Olympic Peninsula. I live in a rainforest. This was the Solduck River in 2022. And when I put this picture on my phone, the phone labeled it as a gravel road. So the phone's AI said, this is a gravel road, but it's actually a stream channel for one of our most productive steelhead rivers. But at this point in time, in early October, nearly the whole stream was dry in several places. And this is the Elwah River in 2022. Most summers, it has a stream flow of somewhere between 50 to 100 CFS. And in this shot here, it's running at about 25 CFS. So at a very low level, water was very warm. And this is the Hoh River, which is glacially influenced and normally runs kind of that turbid gray color associated with the glacial influence. But even it got down to less than 200 CFS for a very brief period, breaking all of its record lows. It was running over 70 degrees. So even some of our more resilient streams that have headwaters and parks and a lot of, or at least more glacial influence, were also running low. But that's not all of it. One of the challenges for steelhead is they like to spawn in these little tributaries, right? That's kind of how they make their bread and butter in a lot of our watersheds. And they deal with many streams, especially in places like the Rogue River that naturally go dry. So fish have evolved behaviors to take advantage of what we call these ephemeral streams, right? They run free with water from the winter and the spring and fall. And in the summer, they may go completely dry or they may go ponded. And we have an example of that on the OP, which is the North Fork Elwah. It's a critical tributary. The Quileute tribe's traditional knowledge indicates that this river, which is about 30 miles long, has about a 10 to 15 mile reach in the middle of it that always went dry. And the tribe had noted that. And it was a place that some of their young men went on spirit quests for. The challenge that we're seeing now is, despite it being so important, that with the droughts we're having, over 90% of it, rather than just about 50%, is starting to go dry. And so this is a picture in early October when the entire lower 22 miles of the North Fork Elwah went dry. That means every juvenile steelhead and coho, all the adult whitefish, all the adult cutthroat, and the few adult wild summer steelhead that were in there all died. And we're talking tens of thousands of fish that died. And unfortunately, the same thing happened this year. This pool is actually 17 feet deep. Again, completely dry. These are just photographs of the thousands upon thousands of dead fish. Up here on the right-hand side, you even see lamprey. So these juvenile lamprey will burrow down into the mud and live there for about 6 years before they emerge and then migrate to the ocean. There was so little water that even the lamprey had to come out from their mud cocoons. But it's not just here. If you look to the upper left, that's the Skeena River in 2018. Large sections of the Skeena River, many side channels went dry, became dewatered. Again, thousands of fish died. You can see Nika's Cove up in British Columbia on the right-hand side. Again, a drought, and that resulted in depletion of oxygen because there were simply too many adult pink salmon in it, resulting in a mass die-off. And so this is something that's occurring region-wide and is becoming more frequent in regions that people typically don't think of as being drought-like. And this shouldn't be something that we think is new. There's been natural climate variation for a long time, and our European ancestors have long acknowledged that. If you looked at some of the news that happened during that drought year in 2022, there were a number of places in Europe where people discovered or rediscovered what they call hunger stones. And these are basically warning rocks that were carved in. And they were carved in during droughts. Some of these hundreds and hundreds of years ago. You can see on the left, it was written in 1161. So we're talking, almost 1,000 years ago, right? And so the concept here was that if you see these stones, you should weep. And that's what one of them says, because that means the drought has been so bad that you're almost certainly likely to lose your crops and struggle. So, before the advent of the Industrial Revolution, there's a long record of these types of droughts. Of course, now we're dealing with something very different, the natural variation in the cycle. There's a clear connection between human influence and changes in climate, and it's going to impact steelhead in other ways. And one of those ways is through smolt timing. So a steelhead spawns in fresh water. Its juveniles emerge and rear for anywhere from 1 to 3 years, generally down in Oregon and Washington, and they will migrate to the ocean sometime in April or May. Generally, that's about when they're going. And so what I did is took some data from the Salduck River just to look at how temperatures may have changed from 2005 to 2020. And the reason this is important is steelhead smolts are pretty thermally restricted. Once a winter run smolt experiences a temperature over 12.6 Celsius, somewhere in that 53, 54 degree range, once that water gets above 54 to 55, the fish can no longer smolt. The impact on its body is too great. And for summer runs, it appears they can handle a little bit warmer water for smolting. But the point here is, if you look at up here, we've got the mean temperature, and the upper orange one is the max, and the low one's the min. And these little gray bars that I've got up there, those are the threshold areas in which once the temperatures get to that point, the steelhead smolting process stops and it reverts. And so what we can see is that in April, things look pretty safe still. Some of the peak temperatures do reach up into that critical window and threshold. But overall, April appears to be pretty safe. On the other hand, May has been the normal month in which most of our steelhead smolts go out. And as you can see in May, the average temperature is now up into that window in which it's high enough to inhibit smolting, and the max temperatures are well above the thresholds at which smolting is inhibited. So what this means is that smolts are going to have to migrate out to the ocean earlier than they do now on the OP. And this is not uncommon. The further south you go for steelhead, moving down into California, those fish don't out-migrate in May because there's not enough flow in that climate. So they immigrate to the ocean anywhere from February to March to April. And so as you move north, the time of smolting gets a little bit later. As you move south, it gets a little warmer. So the point is, the climate is changing, and it's not just that steelhead will adapt to, surviving drought and stream flow. It's also their timing of smolting will likely have to change. The other, and this is kind of something that I don't think as many people are aware of, it does not affect as many of the Oregon steelhead populations, at least that we know of, as much as it does some of those steelhead populations from the Columbia River northward. But there's been an increase in competition, and the ocean is changing. It's becoming warmer, and it's becoming more acidic. And we have about 5 billion salmon in the North Pacific. 40% of those are hatchery. And this is a big change. Actually, I think it's 6.5. I'm gonna lose the number because this 5.5 billion hatchery salmon is wrong. It should be 3.5. So I think we have 6 billion salmon in the ocean. 3.5 billion of those are hatchery, which accounts for about 40%. And this is a big change. In the 1960s, there was just 0.6 billion hatchery salmon. Approximately 70% of those hatchery salmon are pink. A lot of those come from Asia, both Japan and Russia. But there's also a substantial amount that come from Alaska, specifically up by Prince William Sound. And so the question is, the ocean is the productivity, the fundamental chemical aspects, right? The temperature, the pH, all of these things, the currents that move the water around are changing with climate change. And so there is a growing body of evidence that suggests that these very large releases of pink salmon are having a wide range of negative effects on many different populations of salmon and steelhead. And most of these pink salmon, of course, are released simply to be bought back, and their eggs are used as caviar. Maybe they go into some dog food. They may go into some of the canned food, but they're usually not being eaten at a table. And so the question for me is, can we overfill the ocean past its capacity with hatchery fish? And there's been a number of people doing research on this topic. This is not something that I have personally studied, but there is a scientist named Greg Ruggiero. He's kind of spearheaded a lot of this work. So I'm going to cite his work and discuss it here. So hatchery pink salmon, based on his work and others, are linked to reduced growth, size, survival, and abundance of sockeye, chinook, coho, chum, seabirds, and even whales. So it's pretty stunning, the effects. And the reason we can determine this is because pink salmon have an alternating life history pattern, right? They only show up in freshwater every other year. And so that provides basically a rare situation where you have an experiment. One year they're in the ocean as adults, and the next year they're not. And those alternating year patterns allow us to better tease out relationships. What you see here on the right is a relationship between Alaskan Chinook salmon weight, like the weight of individual fish, and the relationship with pink salmon abundance in the millions. And basically, that's a really tight linear model that suggests that the weight of Chinook salmon declines substantially as the number of pink salmon in the North Pacific increases. In fact, as you had 250 million pink salmon and the average weight was about 9 kilograms, if you doubled that to 500 million pink, your weight goes down to about 6.5 kilograms. As you get up to 500, 600 million fish, you're almost decreasing the size of those Chinook by half. So this is a pretty strong, tight relationship. We also know there's some effects on plankton. I'll get into that here in just a little bit. And this is the figure on the right. And this kind of highlights, this is data from the East Bering Sea that was collected by Batten et al. And it shows the abundance of plankton in relation to the abundance of pink salmon coming out of Kamchatka in Russia. This relationship is not as strong, but the research is also now 5 years old, and there's been a number of other studies that have kind of surpassed this one that are showing very similar relationships. So it appears that we have a situation where we basically have too many fish grazing the open ocean right now. And the overgrazing of the open ocean is not leaving enough food behind for these other species. And it's believed, based on Ruggiero's work and a number of others, that the marine heat waves, that kind of blob that was out in the North Pacific for about 4 to 5 years, combined with the abundance of hatchery pink and wild pink and hatchery and wild chum salmon, that both of those likely contributed to the collapse of steelhead from 2020 to now. And so this is a relationship from the Thompson River in British Columbia. And again, it shows that it's just showing the steelhead residuals of a stock recruit model on the y-axis. And then you've got pink salmon biomass down below. And again, it's just a very similar relationship to what you saw with Chinook salmon. The more pink salmon that are in the ocean, the less steelhead we have returning to the Thompson River. So these pink salmon are influencing, as Greg Ruggiero says, everything's from diatoms to killer whales. They're having what we call bottom-up effects. They're consuming so much of the plankton that it's triggering a trophic cascade that is having a broad range of negative effects. Now, I'm going to talk, I talked about smolt timing and that steelhead are probably going to need to smolt earlier in the year than they did historically. And one of the ways they can do that is to simply grow faster. And that's probably going to happen. As temperatures warm, steelhead likely grow faster unless those temperatures get to a point at which they exceed their thermal capacity for growth, right? And then the fish doesn't grow. Temperatures might even get to the point where they're lethal and the fish can't survive there. But another way they can adapt, other than simply growing faster, is they can spawn earlier. And that earlier spawning gets the eggs hatched earlier in the season. Their juveniles, therefore, have a longer growing season. And so what we did on the Olympic Peninsula, and I think I've mentioned this maybe to you all before, but we decided to look at how much run timing has changed for Olympic Peninsula steelhead. And we looked at populations in the Quileute, the Hoh, the Quinault, and the Queets rivers. We had historic data from 1948 to 1960, and that data allowed us to compare catch per unit effort to modern data from 1980 to 2018 or 2017. And the reason we wanted to determine if run timing has changed is because there had been a hypothesis that the advent of Washington's modern hatchery steelhead programs, which are selected to enter the river in November and December, that the onset of those fish, both through competition and overfishing, could have contributed to the decline in early time steelhead. And so one of the ways that can happen is through fishing. And so one example here is this is the fishing schedule for gill nets on the Quileute River. And what you can see is that those black bars represent the number of days a week the river can be netted. And so you can see from November through early January, the tribe is netting 4 to 5 days a week. And the reason they're netting so many days a week is to try and harvest those hatchery fish at a really high level so they don't go, to waste. And then as you get into later in the season, when there's more wild fish, the number of days that they're fishing drops to 1 to 2 days a week. And so it's that part there early in the year where there's this fishery focused on hatchery fish. And I'm not pointing a finger at the tribe. There were decades in which sport fishermen were fishing and killing fish early in the year. This is just an easier way to illustrate how we have a shifting intensity in fishing. And that shift in intensity is due to people trying to harvest the hatchery fish. So the question is, has that early timed harvest also resulted in some change in the run timing? And it is. This is for the Quileute River. What we see on the left is we've got 3 different curves. The blue curve is this really narrow one. That's when the hatchery steelhead, that's their run timing based on catch. And then what we've got here with the green line, the orange line, that's our contemporary wild run of steelhead. And you can see there is some overlap down here, but not a lot. And then the green line in the very back, the kind of clean bell curve, that's the historic timing at which steelhead were caught from 1948 to 1960. So if you look to the right over here, we've got cumulative differences in historic and contemporary run timing. The historic timing is on the left, and the contemporary timing is on the right. And what we see is that the time at which 50% of the steelhead enter fresh water in the Quileute is now 26 days later than it was back in the 1950s. So we've lost about a month of the run timing. And what you see over here, of course, is that it appears these hatchery fish have just simply replaced the early time wild fish that used to exist. And this is not limited to the Quileute. The same pattern exists in the Hoh and the Queets rivers. In fact, it's even worse in the Hoh, where 50% of the run now enters 61 days later than it did historically. And in the Queets, it's 54 days later. So we've really compressed these runs into a much narrower window. And all of this is important because the further south you go, the earlier in the season winter steelhead enter. And that is because they have to spawn in winter or spring. And their juveniles have to emerge from the red before the onset of summer low flows. So spawning in June isn't going to do you much good, or even May in some places in California, because onset of summer low flows have already occurred and their juveniles will be stranded. So if these fish are going to keep up with climate change, they're going to have to begin to rebuild and display those early time fish. So this is just an example of the Columbia River from a paper that was done by Robards and Quinn. And it's a historical analysis, much like ours was. And what you can see here is that historically there was an early and late run timing. They called that a bimodal timing. That was from 1939 to 49. You move right just kind of over the decades, and what you see is that the whole run kind of becomes homogenized, right? You've lost these two bimodal peaks, and now you're into kind of one simple bell curve. And that bimodality has, of course, simply put, become unimodal. And so these things have merged together. And so it appears that, changes in run timing are not limited to winter steelhead. We've seen similar changes in summer runs. Last is this one is one of the more interesting ones for me. I love to winter steelhead fish. I love to steelhead fish, and my dad and several of his colleagues were the first people to get catch and release of wild steelhead in the Columbia River Basin and certain rivers back in the early 1980s. We thought that it was very important at the time that steelhead were in decline. It was time to stop purposely killing them. So I kind of grew up with those people that established those rules. Now here we are, 40 years later, and we've become very effective at catch and release. The steelhead numbers have continued to decline, and now we're looking at fractions of what once existed. An example of how efficient we became is that in 2014, the Department of Fish and Wildlife estimated that every steelhead that escaped to spawn in the Hoh was caught 1.4 times by an angler on average. In the Toutle River in 2015, every steelhead was caught 1.3 times, 2 times in the Washougal River the following year. So we're catching a lot of our steelhead. We've gotten very good at it. And while the mortality of steelhead due to catch and release is pretty low, like 3 to 5%, we don't have a very good understanding of what I call sublethal impacts. And that is, you let the fish go, you've gotten a photo, you're smiling and happy, everything feels good. But now what has happened? What we do know is that catch and release changes the blood chemistry of the fish in a way that would be like us going through a boxing match, right? The stress hormones increase, and the fish respond in various ways. But it's only been recently that we've tried to track and see whether or not fish that are caught and released have any difference in survival of their offspring. And so the first studies to look at this was Steve Pettit back in 1977, a good friend, and he found that catch and release did not impact survival to the eyed egg stage. They stopped looking. Idaho repeated that study in 2019. It was published. And again, they found that fish that were caught and released versus those that were not, there was no difference in the survival to the eyed egg stage. Unfortunately, There was another study done in Oregon, and it was just published this year. And what they did was, this was in the Elwah River, and they had anglers go out and catch winter steelhead and bring them to the hatchery to use for broodstock. And then they also had fish that voluntarily swam into the hatchery. Both groups of fish, the ones that voluntarily swam into the hatchery and the ones that were caught, were wild. And what we see over here on the right is the amount of offspring per brood year. And the angler caught fish is AC, and the TC represents trap caught. And we can see that there's a pretty clear and significant difference in both years. The angler caught steelhead they produced 46 to 53% less offspring than steelhead that were not caught and released. Most importantly, they found no effect at the eyed egg stage. All the effects occurred at older life stages from fry to adult. And that hits back at the Idaho studies just didn't take their research far enough. You couldn't stop at the eyed egg stage. So the hard part here is that captured individuals were also held in the hatchery for longer periods. So it's very difficult to determine how much of their loss in fitness was because of stress related to sitting in a concrete raceway, or how much of that stress was due to them being caught and released. So one of the ways to try and answer this question is to look at Atlantic salmon. So if those fish in the Oregon study lost about half their fitness after being caught and released and taken into a hatchery, what do we see in Atlantic salmon? Because they show really the same patterns in catch and release mortality. They show almost all the same results that we see in steelhead. And there have been a number of studies on Atlantic salmon, more of them compared to steelhead. So again, a study by Booth et al. In 1995 found that no effect on egg production, so catch and release did not affect the number of eggs, but significant and more in-depth studies that actually caught fish, tagged them, and then went out and genetically looked at how many offspring they produced. Two of those found reduced reproductive success, particularly in larger females. And the last most recent study in that follow-up found that there was a 27% reduction in offspring from females that were caught and released. They also found that there was a faster fungal spread. So another study found some fewer eggs. Males at sometimes can actually see a benefit, apparently, from stress. They can see some increased sperm motility. So the point here, though, is that about 27% reduction in the one study, that would suggest maybe if they were, if the results were similar to what we saw in Oregon, that perhaps half of that effect in Oregon could be attributed to catch and release. We don't know that. I don't know that. The reason for showing the Atlantic salmon work is just to provide more context. So the other question is why? Why does this happen, right? And there's a couple of reasons. One of the leading hypotheses is that when you catch a female steelhead, the cortisol levels in her bloodstream go up very high. And in order for her to reach stasis, she probably doesn't do this on purpose, but some of that cortisol, to eliminate it and reduce in her bloodstream, gets dumped into the eggs. And what we see in eggs that have higher cortisol levels is diminished yolk sac volume, reduced fork length and mast, and increased mortality. So these are like stressed children, right? We know that even human children that undergo tremendous stress from their mothers are born with conditions that make it much more difficult for them to achieve all of the things a kid who didn't have that stress would achieve. So I'm not going to go into all of this, but suffice to say that there is a large body of research on rainbow trout and brown trout, and it's starting to suggest that there is not only the potential for an effect on the fish that's caught and released, but that effect is perhaps transgenerational, that they are passing these effects along to their offspring. And one of the best studies on this is in bass, where they had a number of ponds. Some ponds, they caught the bass and killed them. Other ponds, they caught and released them. And other ponds, the bass were not fished at all. And what they found was that anglers almost universally captured the bass that had the highest fitness potential. And that over time, those bass started to behave differently. And so this is a challenge. We're probably to some degree with catch and release selecting for very aggressive fish, and nature seems to like very aggressive animals, at least in terms of fitness. So again, we don't know that this is happening in salmon and steelhead transgenerational effects, but it would be surprising if it's not, because we're seeing it in so many other species. So I guess in close, I mean, look, things are very tough, and I'm not gonna sugarcoat what we're looking at. I mean, frankly, things look just the same for humanity's capacity to sustain civilization, right? I mean, 70 years down the road, it's possible that, most of the salmon and steelhead that are anadromous are extinct in California. The ocean could be entirely too acidic. It seems like that change is unlikely to happen that fast, but it is almost certain that we're going to see a rolling up north of the distribution of these anadromous fishes as they try and find refuge in colder water areas. But it doesn't mean they can't adapt, because salmon and steelhead have been through similar changes before. 3 million years ago, Greenland was ice-free. 3 million years ago, we had steelhead. So the climate had to have been very different back then. There's no evidence, of course, that steelhead were extinct, because we have evidence that they were around. So one way for them to adapt is to be able to change their run timing and smolt timing. That's going to be critical for these fish. Basically, just changing the timing at which they migrate to the feeding grounds in the open ocean, and then changing the time at which they come back and return to fresh water and spawn. But also suggests that, one of the reasons that we're seeing declines in steelhead populations, Columbia River north, are these combined effects from having too many hatchery fish in the open ocean, combined with the warm spells that we're having, the increased acidification. And this is something that we at TCA are very serious about. Alaska, we can't influence the amount of hatchery pinks coming out of Russia and Japan, but Alaska produces, I think, an estimate of about 30 to 40% of all those pinks. We can have an effect in Alaska. And so when we're talking about conservation of our steelhead now, it extends well beyond our immediate home waters. The open ocean, the grazing grounds, the feeding areas for all of our steelhead are being altered by large numbers of hatchery fish that are out there. So again, I don't want to spend too much time on this, but I think the life history that will be most pressed to keep pace will be summer steelhead. They're going to have of course, they require a lengthy period, remaining in fresh water over the summer. It'll be very interesting over the course of the next 50 to 100 years. I won't be here long after I'm gone. I'll be curious, what will our steelhead look like? Because it is clear, again, that they can adapt and evolve, and never say never for any of these fish, because nature always seems to find a way. My point is just that the challenges are really big. They're very serious, and we really can't punt the ball down to the next generation anymore. We are kind of, up against it. And so in closing, this is, just a prediction for the potential strong El Nino that we were thought to get this year. It's kind of bad timing to show this slide, because I just read an article last night that suggests the El Nino has kind of fallen apart. We're back to probably, or perhaps, a neutral area. But also, to give you context, tomorrow on the Olympic Peninsula out in Forks, we're supposed to have 60-degree weather in December. So the climate effects are real. That's absolutely abnormal. And so my point is, for all of us that love these fish and want to keep fishing for them, it's time that we do our best to both understand the plight that they're facing, but also try and give back to the fish as much as we can. So thank you very much. And sorry for the relatively somber note, but just recall that for all the challenges that I showed at the end, places like the Klamath and the Elwah are beacons of hope. Salmon have persisted there, and steelhead for millions of years, and we hope that continues into the future. So thank you very much.
Thank you, John. Go ahead and end your share so we can see you. There.
John, you got to end that with Clyde with a little humor.
I know, right?
Somber.
It
That's a
is.
perfect,
Well,
that's the perfect
John,
segue
thank
to
you
cut.
for interpreting this data for us and for all of your work to try to protect our fisheries. Anybody have a question for John?
I do,
This is-
of course.
And
Or whoever.
John, I've fished for steelhead for a long time, and I've heard all the arguments pro and con about wild fish versus hatcheries. I don't know what I believe. But I do look back on the times we had larger runs in our rivers. At those times, they were stocking those rivers like crazy, and the wild fish were flourishing. Can you shed any insight on that? Convince me one way or the other.
Well, so, this is a good question. I was going to present on that. I figured that that one was even maybe a little more negative. So I recently, I'll give 2 points to this. You probably refer to that period in the late 80s, 84 to 87, 88. I was in high school in those years, and that was the best ocean survival that we've seen out of steelhead or salmon in like 60 years of data. So those conditions were so good that everything did well, both hatchery and wild. But that said, there is reason for concern, and one of those is just simply the pink salmon evidence that we showed, right? That we're at the point now where there's basically almost no room in the ocean for any more salmon at all because there are so many hatchery salmon in the open ocean. But I recently did a review, a global synthesis of every study that had been published that evaluated how hatchery fish helped or harmed or didn't affect wild fish. And so, this included studies from everywhere from Japan and Russia to Norway and Ireland to Spain and America. I think there were 206 studies, and 83% of those found some type or form of adverse effect on wild fish. So I think it's pretty clear, based on the science, that the cases in which hatcheries can actually help wild fish are very specific, and it tends to happen when the wild fish is basically very close to extinction, and they run a tightly controlled, well monitored program that releases relatively small numbers of fish. But there are a number of reasons we can look to. I would suggest just looking at where we're at now. I think it was a couple of years ago, right, in the Columbia, when we had, and it's been similar the last few years. I think the Columbia is releasing something like 6 million hatchery steelhead smolts to get back the last few years anywhere between 35 to 80,000 hatchery fish. I'm going to doubt that the Columbia even has 1 million wild smolts to get back about 30 to 80,000 wild fish, depending on the year. So hatcheries are costly. You have to spend money. They have impacts that are bad on the wild fish. And over time, as you continue to inbreed those fish, because they're coming back to a hatchery and you're inbreeding them continually, you tend to see the patterns that we see, which is hatcheries tend to perform and show their best survival in the first 3 to 4 generations of use. And after you start, continually breeding those fish again and again, the survival and productivity tends to decline. And that's a pattern that was observed by Ray Hilborn, a professor at UW, all across the North Pacific. So, from my perspective, hatcheries are not bad or good or evil, but we've over relied on them to the extent that, they're probably limiting our ability to get the returns on the wild fish that we'd like to see. So I don't, that's kind of my take on it as a scientist. As a fisherman, I prefer to catch wild fish, because anybody who's caught enough fish knows that every time, you can tell when you hook a hatchery one, most often they don't fight as hard, right? They're not kind of the same wild animal because they weren't rooted in nature. What I would leave you with, though, is this, is that find an animal that we've recovered where we've basically inundated it with hundreds of millions to billions of domesticated versions and then didn't really stop killing it, right? I mean, this is kind of one of the challenges to rebuild things like wood ducks, sandhill cranes, bald eagles. We had to stop killing them, you know, and wild turkeys are an example where we both had to stop killing them and then they took and transplanted turkeys from another area. But again, I think that this money that comes out for us, because for populations that are under the ESA list, there are goals to try and recover them. So I think we're at a point now where if the climate wasn't changing and fish weren't under such strong selection from nature, there could be a stronger argument for hatchery fish simply for fishing. But these hatchery fish do not have the capacity, the same capacity to adapt to climate change as wild fish do. And so that is my main concern right now, is just that the genetic diversity is greatly reduced in hatchery fish compared to wild fish. Wild fish have proven over the millennia that they can make it through these types of conditions. But I understand that people may disagree. So I don't necessarily want to convince you one way or the other. I think people should make their own decisions, definitely.
Based on the data.
Yeah, I mean, look, when I look at 200 studies and over 80% show negative effects, it's not really much different from looking at the research on the effects of tobacco on human health, right? You know, there's always some proportion of humans who don't respond to tobacco effects the same way and can live their whole life despite smoking several packs a day and drinking a lot. So yeah, to me, it's as conclusive as you get. We've got, 50 years of research telling us that they commonly have adverse impacts. They pose a great risk. In emergency cases, they can be used to rebuild a population in the short term. And, there are not just tribal, but there are also reasons for hatcheries in some areas. They're legally obligated through mitigation agreements. Some dams, some tribes erode those. So I tend to stay out of that right now. But just from a science perspective, yeah, I think that we over rely on them too much.
Shandy, you had a question?
I do. So, John, since I've been in Douglas County now for 3 years. And while Douglas County doesn't retain wild fish, obviously, the Rogue still does. And is it, I think, Coos. Oh yeah, Coos down there. Catch and release. I've had a kind of a big turnaround about catch and release. I've kind of gone like harvest mentality. I've kind of gone full circle actually. And based on the repeat catching of catch and release. And it's the guides and the outboards. So OP, are those rivers, are they open to motors?
No motors. No, we have those banned.
Okay. So the North Umpqua, it's still motor on the lower part, right?
Yeah.
I mean, you'll see guys just doing loops, just like back and forth in the holes. And it's, it'll be a fly guide even. And it's like, it'll be like, oh, well, we're catch and release, it's okay.
Totally.
I'm like, but it's not really, because you just hit that fish like how many times, if not your boat, the next boat, or once it has a bit of a reset. What are your thoughts on, I mean, if I could like introduce a bill, it would be no outboards, row yourself back up there. If you want to go through it again, row yourself back up there.
Yeah. I mean, I'm with you, Shandy, and I'll be frank on this because I'm an angler and I've had to change my methods over the years and also reduce the number of days I fish a year because I don't want to have the impact after, as you learn more, I alter my behavior. So I agree with you. I mean, look, nobody's using motors to get up to shoot these big, beautiful bull elk in limited hunt areas where you still have big wild animals left, right? I mean, yeah. So I think we need to, I think fish probably get short end of the stick because they're fish and they're underwater and people don't think about them that much. But I'm with you. Look, I think that we've gotten so good at this. and so effective that we need to find a way to control ourselves, right? That catch and release is not some promise that there is no impact, and so you can do it repeatedly and have no effect. That would be silly. I mean, what if all of us were forced to fight Mike Tyson every other day? Like, that would suck, right? But so, because I know people often metaphorically compare this to like running a marathon, right? And then having your head dunked underwater. I'm like, the cortisol levels that these fish are experiencing are way worse than you would get from running a marathon, right? It's nothing like, this is like you're in a fight for your life, right? This animal is doing everything it can, every ounce of energy to survive. And the concern I have is not, if you catch and release, you're going to have an impact. I accept that. My real concern is that we could have selection against big fish, right? Certain fish that are more prone, or fish that enter early. Like if you have a summer seal that enters in June, it's more likely to be caught multiple times than a fish that enters in September because it's in the fishery for so much longer. And that's where
And also coming in.
Yeah, that's where I get really concerned, is that if it's equal across everything, I think that's easier to manage than where you can have early fish get hit harder because they come in so often. And then over time, you might lose your June fish, right? Because they simply can't put up with that much. It's a hard one. I think that the future of steelheading is that when you have wild populations, you're going to have to find, agencies need to first, they need to do the research. They're not doing the right work in a timely enough fashion. And second is, in the meantime, until they do understand, they need to be more conservative, I think, at least for the last remaining strong wild populations we have. I'm more than willing to compromise to some degree and say, at least places like the North Umpqua or the Umpqua as a whole, which is a really important place. So we do, at one end, Switzerland has banned catch and release, and it's only a terminal fishery. And then, you've got other places like Alaska where it's, most of the fishing until at least relatively recently has been terminal, right? And then you've got things like the Deschutes, which has been catch and release forever, for a really long time. So you've got the whole contrast. I'm not sure what the future looks like. I don't know exactly what the effect is, but I do think we just need to find a way to give the fish a little more space to complete their life cycle. And maybe that'll eventually, it's hard to imagine this isn't going to come to limited entry at some point, because there's just so many humans and so little habitat left where a wild fish can actually live its life,
It's pretty wild going to the Clearwater and seeing so much harvest when we've had our rivers closed, like the Deschutes and the John Day, right?
Yeah.
And so these bee runs, I got to witness a bee run, and it was amazing. It was one of the coolest things I've ever seen. This fish was on fire. It was not going to give up, and it didn't. Yet there's still jet boats coming through, and it's just kind of wild that that's allowed.
Yeah, I think,
Shandy, I think we should leave it at that.
Okay.
Okay.
Yeah.
Thank you, John. I appreciate your talk.
Yeah. And all I would say in close is I want us fishing. I think it's totally doable that we can have catch and release fisheries. And I just think there are things we need to account for. It doesn't have to be perfect, but these are just things I want to put in people's minds so that anglers that were aware of what might be coming down the pipe in terms of research, because I'm not sure what the effects are right now because the research is not entirely clear. But just something to look out for, in the coming years as we, try and maintain our loved populations of fish. So thank you for all you guys do.
Absolutely. We have a shared interest. Thank you.
Thank you.
Thanks,
Bye-bye.
guys.
Thanks, John.